Hello there! Today we are going to talk about the Musical Gestures Toolbox for Python, which is a new version of the Musical Gestures Toolbox. And it all started many years ago when I got interested in looking at how we can use cameras to capture human body motion. And then I also started looking at how can you do this with dancers and make music performances based on how you move. So this eventually turned out into a toolbox for Macs with various types of tools and modules for making interactive dance performances. Eventually, this grew also into more of an analytical package. As we started doing more scientific analysis, we realized it was necessary to provide some tools for working inside of MATLAB. And we developed the Musical Gestures Toolbox into a MATLAB package where you can, for example, do trimming, you can do cropping, you can do resampling, you can change different types of things in the features in the image, and most importantly, you can also create motion videos where you can kind of see how the body moves in time just based on the original video image. From this, you can also generate a motion history, and you can create motion grams, which is kind of a visual representation over time of how the body moves. And this is kind of cool because you can then use that to analyze things together with the sound.
Now let us take a closer look at the Musical Gestures Toolbox for Python. If you're familiar with the MATLAB implementation of musical gestures, you will find mostly familiar functions with mostly the same names, but the difference in the Python version is that we are much more object-oriented. This means that we create objects for videos, images, figures, and their lists, and then modify their content via calling processes on these. The greater emphasis on the object-oriented design allows us to have hierarchies in our workflow to have persistent reusable data to maximize our efficiency. When you use the Musical Gestures Toolbox, you render a lot of video, image, and other types of data over and over again. It was very important for us to maintain a fast rendering process. For this reason, in the newer versions of the Musical Gestures Toolbox for Python, we ported most of the rendering functions to use FFmpeg as their backend. This resulted in a 20x, sometimes 30x speedup compared to the previous implementation with running rendering loops in Python. And that is partly because FFmpeg scales so well on the available resources, so you can really benefit from rendering on a server or a more powerful desktop machine. Typically, you start importing your video into an MG object, to which you can apply basic pre-processing just like in the Max or MATLAB version of musical gestures. You can trim the beginning or end of your video file, you can shorten it by skipping some frames, you can rotate it, perhaps to compensate some unfortunate camera positioning, you can adjust contrast or brightness, you can crop it, and optionally convert it to grayscale, which can save you some rendering time in later processes. You can view your MG object, your pre-processed video, at any time either in a window or embedded in a Jupyter notebook. Both have their merits. Playing in a window uses FFplay, which gives you a pretty powerful video player that is not afraid of high frame rates or resolutions and can run independently in a non-blocking fashion, so you can keep coding while looking at the result of a previous operation. However, if you are working in a Jupyter notebook or a Google Colab, it is perhaps more convenient to embed the video directly below the code cell. To do this, you can still use the same show method, but with mode set to notebook. I think the really exciting part of musical gestures starts with the video-based processes you can apply to your pre-processed videos. You can visualize motion by extracting a moving actor from a static background. You can then analyze and extract features of the now separated motion and save it as a CSV file or a set of plots. I particularly like the methods that create motion grams and videograms that summarize the motion or the entire video content in a pair of images, one for the x-axis and one for the y-axis. Sometimes you'll want to visualize the trajectory of motion, either with a simple motion history video or more advanced methods such as sparse optical flow or dense optical flow. You can even track all the joints of a person via pose estimation, courtesy of OpenPose, and save the results to a CSV file or as a video overlay. Since the backend for this process is OpenCV, you can enable GPU acceleration and render up to 100 times faster. The Python version of the Musical Gestures Toolbox also comes with a set of audio processes that can be really useful when you are studying, for example, music-related body motion. With our Librosa-based audio processes, you can easily create figures of the waveform, spectrogram, tempogram, and various other features of your video's audio track. We have also implemented classless function versions of these, so you can use them on audio files as well. A newer feature of the Musical Gestures Toolbox allows you to create time-aligned stacked plots of audio analysis data and video visualizations. To create such composite figures, all you have to do is to collect your motiongrams, videograms, spectrograms, and other data into an MG list, and then call sFigure on it. The first element in your MG list will be at the top, and the last element will be at the bottom of your stack. We take care of all the matplotlib kung fu under the hood, so you can focus on getting your results fast with a few lines of code. That being said, the Python package of the Musical Gestures Toolbox is far from being complete. Speaking of timeline data, in addition to visualization, we would also like to have the ability to export CSV files with the timeline data to feed into further statistical analysis or modeling with machine learning. Just take a look at the issue tracker on GitHub to get an idea. We are also working on adding multicore support to all the rendering processes that use OpenCV as their backend. Finally, we want to develop a comprehensive test suite to ensure the stability and quality of our package on all platforms and in all the workflows we support. That's it. Thanks for watching. Feel free to pip install Musical Gestures, read our wiki pages on GitHub, or browse the built-in documentation.